Phenology is the seasonal rhythms of plant and animal activity, so things like migration and breeding of birds and flowering and leaf color by plants.
The oldest phenological records date back thousands of years.
And those are records of spring festivals at temples in Asia, particularly Korea, China, and Japan. And the festivals were scheduled around the blooming of the cherry blossoms. More recently,
one attraction in coming to the woods to live was that I should have leisure and opportunity to see the spring come in.
Henry David Thoreau kept detailed phenological records while living in his cabin at Walden Pond.
Unlike Thoreau, who relied on the written word to document these events at Walden Pond, Andrew Richardson uses cameras, primarily to focus on the phenological events of plants.
A PhenoCam is a high-resolution digital camera that is used to record in time-lapse mode repeat pictures of a given scene. And over the last 12 years, we've gone from a few dozen cameras across New England to over 500 cameras across the United States, tracking different ecosystem types. Each camera takes an image every half hour from sunrise to sunset, and we are currently getting, I believe, about 1 million new images every month, from agricultural ecosystems to evergreen conifer forests to grasslands to deciduous forests and so on. So this is in early July, and then all of the images from our cameras are available through our project webpage in real time.
Through a fairly simple color analysis, Richardson uses these images to then document the life cycle of vegetation.
And the basic idea is that through a combination of the red, green, and blue primary colors, we can simulate colors as they are perceived by the human eye. And what that means is that our camera images have 3 layers in them, a red, a green, a blue layer, and we're basically, for the area that corresponds to the vegetation that we're interested in, we're quantifying how bright or intense the pixels are in the green channel relative to their overall brightness. And what we see is that when leaves come out in spring, when they expand, the greenness of the vegetation increases rapidly and the blueness and redness doesn't change much. And so that means that the relative greenness increases, and that gives us our indicator in spring. When leaves change color in fall, as they become more red, they become comparatively less green. And so we see a decrease in greenness in autumn.
This data has direct applications to the management of agricultural ecosystems.
One thing we're doing a lot with is taking the phenological data we're getting from our cameras and using that to develop mathematical models of how phenology responds to variation in weather. And then we're using those models to make projections about how phenology will shift in the future in response to climate change. And it's only really in the last few decades that there's been a recognition or understanding that phenology is sensitive to climate change and climate variability. And so since the 1970s, there have been quite a few studies showing that with the rapid increase in air temperatures over the last 4 decades, we've also seen shifts in many phenological events. This is over 9 years across the x-axis here. Things like spring flowering and spring leaf out are occurring by about 2 to 5 days per decade earlier than they were in the 1970s. It matters to everyday people for sure. If the phenology of flowers shifts at a different rate than the phenology of the insects that pollinate those flowers, then the pollinators may not be there when the flowers are looking to be pollinated. And that can cause all sorts of problems, both for reproduction in forests, but also for crops.